All right, guys. So we're going to take notes on evaluating trig functions. So this is going to be our page 28. Evaluating trig functions. Do something a little different here. All right, evaluating trig functions. So what we did in our notes from yesterday was we evaluated trig functions of acute angles. Okay, so that was the 45, 45, 90, 30, 60, 90. All of that was, we evaluated that. But now we will evaluate trig functions of any angle. Okay. Here's a general definition of trig functions. We did specific before the SOHCAHTOA, but now we're going to get into another definition. DEFN means definition. So, to give a visual here, okay. So remember our initial side here. And we have our vertex at the origin and our terminal side. All right, this point, we don't know what it is, so we're gonna call it XY. All right, from the vertex to this point XY, this is our radius. Okay. This is our theta. And our XY, right? We know if we come straight down here, this is our X. And then from this point to this point is our Y. Right angle, theta there. Okay. So here's our definition. Let theta be an angle in standard position. And let xy be the point where the terminal side of theta intersects the circle x squared plus y squared equals r squared. All right, and so that's what's happening here, right? The terminal side is intersecting the circle, which we defined as x squared plus y squared equals r squared. So how can we define our trig functions? Okay, so sine theta is equal to, right? Remember, opposite over hypotenuse, right? SOHCAHTOA. So we can be reminded of that here. So that's how we're defining it. Opposite over hypotenuse, so that's y over r. So sine theta is y over r. Our cosine theta is adjacent, which is x, over hypotenuse, which is r. So this defined as x over r. And then tan theta is defined as opposite over adjacent, right? Opposite over adjacent. So that's y over x. Just make sure x is not 0. And then we can go ahead and find cosecant of theta, which we know to be r over y, just as long as y is not 0. Secant of theta, we know to be r over x, as long as x is not equal to 0. And cotan theta is x over y, just as long as y is not equal to 0. So let's say, for example, we want to let -4,3 be a point on the terminal side of an angle theta in standard position. And remember, we know something is in standard position when the initial side is on the positive x-axis and the vertex is at the origin, and then the terminal side is, wherever. Now we want to evaluate the 6 trig functions of theta. Okay, we want to evaluate the 6 trig functions of theta. Now, I always like, for the first thing we do is to draw a picture. So let's do that. Let's draw a picture of this situation. Okay. So, of course, x, y here. So let's make a point at negative 4, 3. 1, 2, 3, 4. Up 3. It's about here. I always like to use a straight edge, and I end up using my D. Okay. And so, to keep this the way we want it, all right, we know this is 4, or negative 4. All right. We know from here to here, our y is 3, and our theta is here. And now that we've drawn this situation, right, for our standard position, we know the initial side is here, right? That's the initial side. The second thing we need to do is to find our r, okay? We need to find r. And we can do that by Pythagorean theorem or use the Pythagorean triple. All right. And so once we use that, 3 squared plus negative 4 squared equals our c squared. That's 9 plus 16 equals c squared, or 25 equals c squared. Take the square root of each side, and we have our c is 5. So our r is 5. Okay, our r is 5. Now that we have that, we can define our 6 trig functions using the definitions that we came up with right up in here. Just to keep us focused, it's okay to box this in so you can easily refer back to it when you start doing homework and practice. Okay, so when we come down here and do our sine theta, we know that's y over r. Remember, our y is opposite over hypotenuse. So our sine theta is 3 over 5. Our cosine theta is x over r. X, or adjacent, is negative 4 over 5. Our tan theta is defined as y over x. Y is 3, x is negative 4. And yes, you can still use opposite over adjacent, but we're graduating to, y over x, right? And then for cosecant theta, we know that that is r over y. Our r is 5 over y, which is 3. Our secant theta is our r, which is 5, over x, which we know to be negative 4. And finally, our cotan theta is x over y, so that's negative 4 over 3. So we've defined our 6 trig functions, okay? So that was our step 3. All right, that was our step 3. Go ahead and evaluate the 6 trig functions, which is what was being asked. Now let's talk about the unit circle. Okay, we're going to talk about the unit circle for a second. When we talk about the unit circle, you probably have heard of this, which is good. The unit circle is when R is 1. Okay? It's when our R is 1. So the circle, x squared plus y squared equals 1, with center being 0, 0, and R equals 1. This is the unit circle. So now when we define our sine theta, for instance, and I'm going to use this color just because it makes it easier. When we have our sine theta, instead of y over r, we know r to be 1. So our sine theta is just y. Our cosine theta, since r is 1, we can just define it as our x. And then finally, our tan theta, we can just define still as y over x. Okay. All right, I'm going to flip this over just because I don't think I have enough room for what I want to do. I don't think so. So let's flip over. Okay. So let's say, for example, we want to use the unit circle to evaluate the 6 trig functions of theta equals 270 degrees. Now we absolutely want to look at the graph of this. So let's go ahead and make our graph. Okay, so remember this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, right? Now, if we're evaluating at 270, we're looking here, but the unit is the part we need to look at. Because our unit is 1, what that means is we're looking where here would be 1, 0. Here would be 0, 1. Here would be negative 1, 0. And here, which is our focus, is 0, negative 1. So remember, our focus is right here at 270. So when we evaluate sine theta, remember that that is just y. What is our y here? It's negative 1, right? So I said sine theta, but don't forget theta is 270. So sine of 270 degrees is negative 1, right? Because that's the y. All right, when we look at our cosine of theta, which is cosine of 270 degrees, we just look at our x, which is 0. All right, when we look at our tan theta, that's still y over x. So that's negative 1 over 0, which is undefined. Okay? And then cosecant of 270 is still -1, because -1 over 1 reciprocal is still -1. For our secant of 270, that's 1 over 0, which is undefined. And then our cotan of 270 initially was undefined, but if we take the reciprocal of that, that's 0 over 1. So it's 0 degrees. Okay? That's 0 degrees. So now what I want you to do is take some time, go to page 867, and complete numbers 1 through 4. And then we're going to get to part 2 of this video.